question 3 is in explicit notation. Instead of just telling us that this is f of x or g of x or some function, they tell us the actual equation. And we recognize this from our colored papers. This is the square root of x. We want to graph y minus 2 equals negative square root of 3x plus 3. So I'm going to start off by rewriting that. You notice that you do have here a horizontal compression and a horizontal translation. So this is where the note comes into effect. Before we do anything, this needs to be written in factored form. So I factor out the 3, leaving me with x plus 1. And then I'm going to move the 2 over to the other side. And I start labeling what each of the numbers does. So my original equation was square root of x. Now I have a negative out in front, a 3 inside, a 1 inside, a 2 outside. So this negative outside is vertical. It'll be a vertical reflection. We will multiply our y values by negative 1. The 3 inside will be a horizontal compression. We'll multiply our x values by 1/3. The plus 1, a horizontal translation, 1 to the left. So again, if you didn't notice that factored form, you'd be tempted to go 3 to the left. And finally, the plus 2 is a vertical translation. We're going to go 2 up. So we set up our points from our original graph. What are the key points from our original graph? Normally, they would be those 3. 0, 0, 1, 1, and 4, 2. But I'm going to take a look at what I'm doing. In particular, I noticed that I'm going to have to multiply my x coordinates by 1/3. So I might, instead of choosing one of these points, what's the next nice point on your square root graph? Can you see that you would have 9, 3? Square root of 9 is 3. Choosing that point will be nice because I can multiply the x coordinate nicely by 1/3. What I'm going to do is I'm going to take my original point. Definitely you have to take 0, 0 because that's your starting point. I'm going to do 1, 1 just to see what it looks like when you're dealing with fractions. But I'm going to choose 9, 3 because it's nicer as far as coordinates. Draw my arrows for stretches and compressions. Draw my arrows for translations. And above my stretches and compressions, I'm going to write them down. I have to multiply x by 1/3 and y by negative 1. So I need to go 1 left and 2 up. So when I multiply x by 1/3, this one's nice as 0. This one becomes a fraction, 1/3. This one is 3. Multiplying y by negative 1, still 0, 0. This is now negative 1. This is now negative 3. 1 to the left, negative 1. And here, 1 to the left is a little bit tricky, because you would have to do 1/3 minus 1. Okay? You can do that mental math perfect. If you're looking at it and you're saying, how do I subtract fractions? I need to have a common denominator. 1/3 minus 1 is the same as 1/3 minus 3 over 3. Will become negative 2 over 3. And then 3 minus 1. So what I wanted to show is that it's not wrong to use fractions, but it was sure a lot easier to use the numbers that didn't have fractions. And finally, we need to go 2 up, plus 2, plus 2, plus 2. And graph it off to the side again so that our original graph is not too busy. We're going to have the point negative 1, 2. Negative 2/3, 1. And 2, negative. The shape of my graph needs to look like this because I've had a vertical reflection. So sometimes you also think about just what's happening to my graph. This vertical reflection would flip it down. My graph needs to have that look like it's been flipped down, so its curve is similar to the original curve. Now that I have my graph, I reread the question, I realize, oh, they're also asking for domain and range. My smallest x value is -1, so I can write my domain that x has to be bigger than or equal to -1. I don't have a smallest y value, but I do have a biggest y value, so all my y values are less than or equal to 2. Questions for practice on this one? Please circle 8 and 10.